So right now you should be doing 15, 16, and 34, which if you watched the video last night, you know how to do them. Stop. You're going to be gone. No. I can't see well.
Stop. I said it right.
And it's on your paper. Ashley, is that air on?
What numbers?
Yes.
That's subtraction sign, right? Or division?
Adding. No, because you're not going to hear that.
What
Adding.
numbers did you say?
15, 16, 34.
15. Oh,
What number did you do against that, man?
16. 15, 16.
Was that you or me hitting stuff?
Hmm?
Did you hit something or did I hit?
that was you.
Huh?
That was you.
Okay. We're done with 15, 16, and 34. For 15, I distributed, and I got the square root of 6 times the square root of 2 gave me the square root of 12. The square root of 6 times the square root of 3 gave me the square root of 18. Now, what can these two be broken down? Yes. What's the biggest perfect square that goes into 12?
4.
And you get 4 and 3. And so that's where I got 2 root 3 from. Then what's the biggest perfect square that goes into 18? So that's 9 and 2. And what's the square root of 9?
3.
So that's where the 3 root 2 came from. For number 16, you would distribute, and you would get the square root of 16 plus the square root of 24. Do both of those break down?
Yeah.
16 is a perfect square, so what's the square root of 16?
4.
All right, and what's the biggest perfect square that goes into 24? 4 and 6, so that's plus 2 root 6. Dun, 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 dun. Magic. Did anybody get those right? Hey, that's exciting. The Fab won.
What did you multiply? She just.
I distributed. I multiplied the square root of 8 times the square root of 2, and I got the square root of 16. Then I said the square root of 8 times the square root of 3, and I got the square root of 24. The square root of 16 is 4. 24, the biggest perfect square that goes into it is 4, and that gives you 6, so it's 2 root 6, because the square root of 4 is magic. Alright, let's look at 34. This one's a little bit different because we have a number out front. Do we multiply the square root of 5 times the 6 or times the root 2?
Root 2.
Times the root 2. Alright, so root 5 times 6 root 2 is 6 root 10 minus. What's root 5 times root 5?
Root 5.
And what's the square root of 25?
5.
5. So it's just 5. That's all you have to do. Does anybody need one more of those?
I do. I do.
Do I need to leave this up here for another minute? Alright, please turn your paper over. This paper with our notes, we're going to turn it over, and on the back we're going to write distribute C. please work that one out without me.
So you multiply the 5 with 2?
Yes. I would also check Google Classroom for the answers for 1 to 10 on your study guide because they're coming down shortly.
Okay.
Did you see him?
It bounced.
Yes. Carly got me long-lasting ones.
Harley Logan?
Yeah. Are we done with this problem?
Yeah.
All right. So did we, when we multiply, get 3 root 10 plus the square root of 40?
Yeah.
And did you break 40 down into 4 and 10?
Yeah, I got that one.
So then you get 3 root 10 plus 2 root 10. But wait, can we go a whole step further?
Yeah.
Yes, and you end up with 5 root 10. Did anybody get that one right?
No.
Hey, the Fab 3 this time. That's exciting.
3?
I'm going to start caring as much as you guys do, and we'll see how much fun that is. See how much you learn. Do we need to do one more? Are we good?
Yeah.
The heat isn't on.
Turn the air on higher.
I can't hear when it is.
Isn't that good thing?
It's not like y'all are saying anything anyway. I hope something magical happens with this one.
Bet it won't.
On the last one, how did you get
It's gonna
40?
look like SpongeBob.
On the last one, how did you get 40?
Oh my goodness.
8 times 5 is 40.
Come here.
Come on, buddy.
So you added the 3 and the 2.
Bubble Buddy.
No? What are you talking about?
The 8 times 5. I see a 3 and a 2 plus 8.
You multiply the square root of 5 times
Oh.
everything.
Okay.
That was pretty cool.
Something magical did happen. Yes. I'm sorry, I'm fine. Yeah.
Your face
I want to
is
answer
so
what I'm
excited.
saying.
Come on, you can't. You can't.
Shut up, you don't owe mine.
Easy.
5.
5. You owe me 5.
And that's 5.
You might not put my name.
What?
Yeah,
Wow.
What?
Wow.
Wow.
You don't get that every day.
No, we did. Yeah, we did.
What is that?
For what?
The-
It didn't get kicked off.
Oh, you got it right. Put on that.
Put on that, we did.
Put on that.
I got it right.
Did you mess up right here? Okay, so it's root 6 times root 6, and that leaves you with just 2 times 6. Because it would be 2 times the square root of 36, and the square root of 36 is 6, so you get 12.
Wow.
Okay,
So, can you do the first step? Okay, Miss Asbury. Why would you not use the square root of 36?
The square root of 36 is 6. So I did, yeah. I just simplified, yeah. So you do the square root of 6 times 4 root 3, and you get 4 root 18. And then you do the square root of 6 times 2 root 6, and you get 2 times 6. Because remember, root 6 times root 6 gives you 6.
So you can do like, so you just, how much time you can do that?
Because the square root of 6 times the square root of 6 is the square root of 36. The square root of 36 is 6.
That was 5, 6.
Oh, that's Satan right there, big fella.
Alright, so please get out this page right here. I put it on your tower. You have 2 pages that you should have on your tower. You have one that looks like this, and then you have one that looks like this. This is radical equations at the top. Did I put both of them on your tower or just one? I mean, on your table?
This one.
Which one are you missing?
I don't even know what the first one is. Somewhere.
Right there.
I have this one.
Alright, so this last part of our lesson together today is going to be radical equations. It's really not that difficult. You just have to think a little bit, so it might be difficult.
I just rolled around the school on a red bike. Did you know that? You didn't hear me ring my bell outside your classroom.
Was I in a classroom last year? Alright, so now we need to label the parts of a radical. Who remembers what the number inside the mullet's called?
Did you say predicate?
That guy's called the index. What is this guy right here called? That's the radicand, yes.
Metaphor.
So today what we're going to be doing is radical equations. Now, a radical equation looks like the square root of x plus 1 equals 4. Or the square root of x minus 3 minus 2 equal to 7. So the way we would normally, we would have to do the opposite. So how would we get rid of a minus? You would add. How would you, if it was a fraction, what's the opposite of a fraction? Multiplication. And if it was multiplication, what's the opposite of multiplication? So to get rid of a radical, you have to square both sides. So the opposite of the square root is to square it. Now, you're going to sometimes have 2 equations or 2 answers, but you're always going to have at least one. To solve an equation that involves a variable and a radicand, we must get the radicand on one side of the equation alone. In order to solve. Solutions that result in false statements when plugged in. So once you check your work, if you plug it in and you get a false statement, those are called extraneous. And that's how you spell extraneous.
You look like an extraneous.
It's so extraneous. That's a good thing.
An extraneous solution? It's a solution that's false.
It's not like a word, an actual word.
Yes. I did not just make up a word.
No, I'm just saying, like, what's the definition of it without
An extraneous solution is a solution that does not have, that is false. It's on the outside. It doesn't. Okay, now let's look at our first example. We have to get the radical alone, so how do you think we would do that?
Add 4.
Alright, so everybody add 4 to both sides. And we would have the square root of x minus 1 equal to 4. Now, I just told you how you get rid of a radical, but I think 4 people were listening. So how do we get rid of a radical?
You add to both sides. I thought you what you
He was not one of the 4. So how do we get rid of a radical? You square both sides. So if you square both sides, that makes the radical disappear. So you're going to be left with x minus 1 equal to 16.
Oh. I have a question.
I'm sure.
I have a question. So, all you gotta do is just add both sides and then square both sides.
That's not a question.
He's asking if that's
Well, it was. Well, yeah.
I'm not asking for any help from y'all. What's your question?
Look at you, explain like what you do when you know what you did.
What did I do first?
Add both sides.
Both sides.
I added 4. So why did I need to explain that?
You know what I'm saying? Like
Then what did I do from here? I squared it to get rid of the radical. Now what am I going to do? I'm going to add 1 to both sides, so what does x equal? 17. Alright, now let's look at the one over here. What do you think we would do first to get rid of that 2? We can't distribute to the radical. Nope. We would divide by 2. Because it's 2 times the radical. Your goal is to get the radical by itself. So the opposite of multiplication is division. That's why we did that at the beginning where I said, what's the opposite of multiplication? What's the opposite of subtraction? So you have the square root of 3x plus 15 equal to what?
3.
Now how would we get rid of a radical?
square it.
Square both sides.
Check you try.
Alright, so then when you square the square root, what happens to that radical?
It disappears.
And you're left with 3x plus 15 equal to?
9.
Yes. No, you cannot touch anything that's in the radical until it's by itself. Alright, now what would I do from here?
Both sides.
And what would 3x be equal to now?
-2.
So what is x?
-2.
Now, why do we square both sides of the equation? Right, and what's that called?
Oh.
Starts with a B.
Binomial. No.
Yep.
Oh, I thought I said that.
Use the math term.
Well, like,
Let it go. Just let it go. Alright, so you have to balance the equation. Now, what we're going to do on the bottom is we're going to plug in our x values back into the original and make sure it works and is not an extraneous solution. What was our answer for our example? Alright, so we have x minus 1 minus 4 equal to 0. Please notice that my 4 is not under the radical, so your 4 should not be under the radical. Does everybody understand?
Yes, ma'am.
Alright, so what did x equal?
17.
So we're going to plug 17 in for x. Minus 1 minus 4 equal to 0. What's 17 minus 1?
16.
What's the square root of 16?
4.
And what's 4 minus 4?
0.
Does 0 equal 0?
Yeah.
We did it right. Alright, so for the you try example, what was our x value?
-2.
Now everything's under the radical this time except 2, correct? Alright, let's plug in -2 and see what we get. Work it out without me.
It's not
Okay, -2.
You did my what? Check.
I would work it out before I divided by 2. And then multiply by 2 at the end. Like I would multiply those together, then add, then take the square root, then multiply.
question, Jonathan.
Okay?
Did that person did the people get a grade for watching the video?
Yep. Did y'all get 6 equal to 6? You do 2 times negative 3 and you get negative 6. Negative 6 plus 15 equals 9. The square root of 9 is 3. 2 times 3 is 6.
You said 3 times negative 2?
Yep.
Okay.
Because x is equal to negative 2, right?
I was looking at that.
Oh, okay. Alright, let's look at the back.
Well,
No, we can add and subtract and multiply without Miss Asbury. Alright, let's look at number 1. What do you think we would do first?
Oh,
subtract 2 by
Okay, our goal is to get the radical by itself. Is the radical by... Yes, we would square both sides. So then what does x equal?
2x.
4.
Do you see y equals 4? Okay, you square both sides, and the square root of x, the square root disappears, and you're left with x, and then negative 2 squared is 4. Alright, now let's check it and make sure it works. We have the square root of x equal to negative 2, so we're going to take the square root of 4 and see what we get. What's the square root of 4?
2.
Is 2 equal to negative 2? So what kind of answer is this?
Extra.
Extraneous.
Also, this bunch of negatives in there.
Try number 2 without me. What do you think you would do first? Add 7. Alright, try it without me. Alright, so real quick, everybody.
Please, no.
Then don't look at the board. I won't talk, just don't look at the board.
I got 2.
Look at you go.
Oh, go.
I got 2. 2 got I.
Oh, yeah.
Yes, sir. Right here?
Yokohama.
I subtracted 5 from both sides.
How about all the flavored gum?
No, don't be sorry. I just didn't write that stuff down. Alright, so before we leave each other, I want you to please look at number 3.
Oh, there you go, Blair.
Yeah.
Dang it. We want to.
Number 3. Now, the first thing you would do is you would square both sides.
Already?
This is not pack up time. This is pay attention to the board time.
Yeah.
Square both sides, and you get 1 plus x squared equals what? 25.
25.
Yep. Alright, now what would we do from here? And we would get x squared equal to 24. Now, if we square both sides to get rid of a radical, what would we do to get rid of a squared?
Radical square.
Radical, square root. So take the square root of both sides, and that gives you plus or minus the square root of 24. Now, why do you think it's either positive or negative?
Oh, thanks.
It is, but why?
Because of the.
Because it's squared, right? Because you can square a negative and you'll get a positive. You can square a positive and you'll get a positive. Now you have 2 sheets on your desk. You have this sheet and then you have one that looks like this, correct? Tomorrow you are to do this sheet. I would take, yes, with Miss Ronaldo. I would take this time to write down number 5 real quick because 5 is a little confusing. And then you need to work on your study guide tomorrow. Does everybody understand?